So yes, thank you. I'll talk about PhaseSpace and the decay language, a bit more about decay language as well. What I'm be working on is a package called PhaseSpace, which is a package built in Python and using TensorFlow, which you can use to make very simple phase-space generations and simulations of that. And the new feature that I've added to this package is the possibility to load decays from DecayLanguage so that these two packages interoperate quite well. And also it makes it easier to, I've also added some features to make it easier to specify resonances and customize these mass functions and which masses that certain particles should have. And if you want to try it out yourself, there is this Jupyter notebook that you can try out. There are some problems with binder right now, so I'll fix that after the talk. But you can also pip install this package with the from decay flag. So the main package here is PhaseSpace, and the newly added feature is the Gen multi-decay class, which I'll talk a bit about. But before that, I will have to talk about Gen particle, which is another class in PhaseSpace, which can be used to simulate these decays and the phase-space generations. So you can specify a pion, for example, with this Gen particle class, and then you specify the mass here as the second argument. And then you have some other particles as well, like a kaon, a k star, and a gamma. And then you can specify this dot set children and pass in some gen particles to that as well. And this will then, that way you will build up a decay that you later can simulate. And the way you do this simulation is by running the .generate method, and you specify the number of events that you want to simulate. And the output here will be weights and particles. And weights here will be just a tensor of numbers, and particles will be particles here will be a dictionary containing tensors, which will be 4 vectors of the particles that are decaying. The problem with this is that it works quite well, but it's you can't simulate particles that decay in many different ways. So when you have multiple decay chains for a single particle. So this is something that I've added. So first we will just parse a decay from DecayLanguage, as Eduardo showed before. And this will look something like this. So we have a pi0 decaying to a gamma gamma, or e plus e minus gamma, etc., with some branching fractions here. And then what we can do is that we can take this parsed object, which is just a dictionary, and pass it to the gen multi-decay from dict class method. And now you have a gen multi-decay object, which you can, which in turn contains a bunch of gen particle objects, which will do the heavy lifting of running all the simulations. So it's a wrapper around that. Now, just like a gen particle object, you can run the .generate method on this object, and then you will have a bunch of simulations which will give an output. So here around 10,000 simulations, and 9,881 of them were probably this decay, and then there were a few more of this decay. And you can see that the branching fraction here roughly matches the number of simulations that we got out here. Now, this is great. Now we have some kind of layer that works as so you can just take a decay from DecayLanguage and then pass it directly to the PhaseSpace package, and now they work very well together. Another thing that I've added is changing the mass settings for these particles. So when you have a particle, you what it does is that it automatically finds the mass using the particle package that also Eduardo talked about. But you can also specify which mass function it should have for more customizability of the resonances. So you can, for example, set if it should be a constant or a variable mass by specifying the tolerance, which you can pass into the gen particle constructor. This way you can have some particles that decay with a fixed mass or a variable mass. You can also specify which mass function it should be. So let's say that we have this kind of decay of a d star plus, which decays into some other particles. Now the default mass function that we will use for a particle with for resonances will be a relativistic Breit-Wigner function. But if you want to change this to a non-relativistic Breit-Wigner or Gaussian function, you can do that by specifying the zfit parameter. And so you have this dictionary that you got from DecayLanguage, and then if you add a zfit parameter to it, so here I will not explain everything, but here you have a pion decaying to, for example, the gamma gamma, as mentioned before, and then you add this zfit parameter with the Gauss setting. It will use a Gaussian function for the mass instead of a relativistic Breit-Wigner. And then you can pass it to gen multi-decay as before. Now this could be quite tedious if you want, for example, if you want the pi0 to always decay with a Gaussian mass function and not just when it decays to 2 photons. You would have to specify the zfit parameter for every one of these decays, which is quite tedious. So instead, you can add the particle model map parameter to the gen multi-decay constructor, and then you can specify that pi0 should always decay with a Gaussian mass function. Another thing that is quite nice if you want to use the zfit parameter is that you can specify when you make this DecayLanguage dictionaries using the decay mode and decay chain objects, as Eduardo showed, you can specify the zfit parameter quite naturally in this construction process. And then you can pass this, convert it to a dictionary and then pass it to gen multi-decay to create an object. I'm not sure if I have time, but you can also specify custom mass functions. So if you, for example, in PhaseSpace right now, there is the Gaussian, the non-relativistic Breit-Wigner function, and the relativistic Breit-Wigner function that you can use for the distribution of the mass for a particle. But if you want some other distribution, you can even create it yourself with with a function, and then you can pass this to the gen multi-decay constructor, and then you can use custom mass functions so that you really want to, so you can really extend it and customize as much as you want around this these simulations. But the basics are quite easy to simulate. So in summary, PhaseSpace is a package for phase-space simulations using Python and TensorFlow as the computational backend. And this newly developed gen multi-decay class, which I've introduced to PhaseSpace, can be used to make it easy to load and simulate decays from DecayLanguage and make these packages work together quite nicely. Additionally, you can use gen multi-decay to customize resonances and setting the mass to be constant or variable, or having a certain mass function, or even specifying different mass functions for different decay chains of the same particle, and even using custom mass functions. So it's quite flexible, but the basics are quite simple, and it works just out of the box when you want to do simple simulations. So I think that's about it. And if you have any questions, I'm happy to answer those. Thank you.
Okay, thanks a lot. Also, thanks for staying within the 10 minutes.